Hello everyone, welcome to Mhlongo's Mathematics and Physical Sciences YouTube channel. And today we're looking at the Mathematics Paper 1, September 2021 trial paper for grade 12. And our question is question 3, which is under functions. And we're given an equation of g of x, which is equals to minus 6 over x minus 3 plus a 1, whereby the first question says we need to determine the equation of the asymptote. That's 3.1.1. Determine the equation of the asymptote for g of x. As we know, g of x is given as um, negative 6 over x minus 3 plus 1. That relates to the original hyperbola function, which is ax minus p plus q. And in order to get the asymptotes, we get the x asymptote by saying x minus p is equal to 0 and then x is equal to p, which and then for the y asymptote, we just say y is equal to the value of q. Now in this case, our x value, we're just going to say x minus 3 is equals to 0 and then x is equals to positive 3 and then our y is equals to 1. Right. Then 3.1.2, the y-intercept of g, 3.1.2, y-intercept of g, we are going to let x to be equal to 0. And you see from y is equals to minus 6 over x minus 3 plus 1. When you substitute x is equal to 0, what do we get? Minus 6 over 0 minus 3 plus a 1. That gives us a 2 plus 1, which is equals to a 3. And therefore, the y-intercept says that when x is 0, y is 3. 3.1.3, x-intercept of g, the x-intercept of g. Now 3.1.3, when we're looking for the x-intercept, we let y to be equal to a 0. And when we do that, we still have our general equation of g, of which y is equals to minus 6 over x minus 3 plus a 1. Therefore, substitute for 0 here, minus 6 over x minus 3 plus a 1. We transpose the 1 in order to become a negative 1 is equals to negative 6 over x minus 3. And we can divide in here by a 1 so that we can cross multiply in order to get minus 1 multiplied by x minus 3 is equals to a minus 6 multiplied by 1, of which we're going to get negative x plus a 3 is equals to negative 6, and thus being negative x is equals to negative 6 minus 3, of which negative x will be equal to negative 9. But you can divide on both sides by negative 1 in order to get x is equals to a positive 9, such that um, the intercept will be when y is 9, when x is 9, y is 0. And 3.1.4 says sketch the graph of g showing all the intercepts with the axis and the asymptotes. Normally they say the axis and the asymptotes and all the points. So 3.1.4, gonna have to draw the graph. I can label here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Minus 1, minus 2, minus 3, minus 4, minus 5, and 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4. Right. We'll first start by plotting the asymptotes which we determined. The first asymptote or line of asymptote was a x is equals to 3. So we need to draw a straight dotted line here passing through and label it x is equals to 3. Then we also had a y is equal to 1. We label it y is equals to 1. The next thing is plotting the intercept, the x-intercept and the y-intercept. We have a 9 is to 0, so we can plot our 9 is to 0 and we write it down as 9 is to 0. And then we can draw the graph. And then we have a 3 is to, or 0 is to 3. And x is 0, y is 3. So around here going through, missed it. Going through and never touching the asymptote, but going towards it on both sides. And there you have your 3.1.4. We can also indicate that this is the point 0 is to a 3. Second last question says that for which values of x is g of x greater than 0? Now for which values of x is g of x greater than 0? For this question, I would like for you to use a sketch, maybe if you can try and use the sketch. From when you look at the point x is equal to 3 towards the left from the graph, and x is equals to 3, that's where the graph doesn't touch. But from the points that are below here, the graph is just above 0 all the way up to negative infinity. So how do we put that mathematically? We'll write it down. And then also from here, I'll paint this red. From here, from x is equals to 3 all the way up to from 9 here, the graph is below. But as soon as we start from after just 9, we're going towards that side. Then we can see our graph being greater than 0. So therefore, we'll have about 2 intervals that we need to write here. So it's 3.2 point, just 3.2. So in 3.2, oh, I need to change this back. In 3.2, we are looking for the x values that are less than 3 and the x values that are greater than 9. It's as simple as that. In 3.3, the question says that if h of x is equals to x plus c, is the axis of symmetry, determine the values of c. Now the axis of symmetry passes through here. If I can draw it maybe in green, it passes, the axis of symmetry passes through here so that this graph can be reflected to look like this graph. Okay, now I'll remove the axis of symmetry as well. But where it passes at this point, which is the point whereby the two asymptotes meet. And that point, we can call it the point where x is 3 and y is 1. Right. They have given us h of x is equals to x plus c, which also means that there's an invisible 1 here, meaning the gradient is positive, and this is an increasing graph. And the point where it passes through is in 3 is to 1. So therefore, we can use this point, x plus c, to substitute here to say 1 is equals to 3 plus c, and then we solve for c. And as we do that, our c is equals to 1 minus 3, of which is equals to minus 2. Therefore, our equation, even if we're not asked, but our equation will now be x minus 2. Last question is asking us, describe the transformation to, of g to h of x equal to 6 over x plus 3 plus 1. Well, using h of x twice, maybe that could have been a typo, an error from the um, examiner, but we can go with it since we had an h of x in the previous being the what you call being the reflection about the line y equal to x. So anyways, 3.4. So now we're looking at the transformation from g to h of x. So h of x is positive 6 over x plus 3 plus 1. And then our original function was a g of x is equals to negative 6 over x minus 3 plus 1. Now, what do we look for? For h, we have a being a positive 6. We have um, uh, p being a negative 3 and q being a 1 in according to the general or mother graph. And then for G, we have A being negative 6, P being positive 3, and Q being positive 1. So, what change would have happened? Let's start with P, moving P from a negative 3 to a positive 3. I don't know why I start with P, but P is the what? The horizontal shift. Now, if we can go back to this sketch here, if we move this horizontal line of asymptote 1, 2, 3, 4, 5, 6, we will have moved it 6 units to the left. So therefore, the transformation that has occurred here would be um, a horizontal shift to the left of 6 units. And then, what else happened? A moving from a positive 6 to a negative 6. Now that means something has been reflected. Oh, the graph has been reflected. If it's now moving from a negative, because you know that if we have A being negative, the graph is plotted in the second and fourth quadrant. Now it means the graph will be plotted in the first and third quadrant, which means now it's reflected somewhere here about the line or about the y-axis, meaning if you are reflecting something about the y-axis when it was here, you move it, you flip it to here. The x-axis now becomes either from positive to negative or negative to positive. The y doesn't change. So therefore, this would be a reflection. So the second point, the first point is here. Second point would be a reflection about the y-axis. A reflection about the y-axis, of which in this case you have from G, which is we'll just say it's not G, it's just Y, minus 6 over X minus 3 plus 1. If you're reflecting it from just changing what? You're changing the X value into a negative. So where you see X now you put negative X. So negative 6 over negative X minus 3 plus 1 then becomes, now you can factor out negative 6 all over negative x plus 3 plus 1, and then these two we're going to divide each other and end up with a 6 over x plus 3 plus 1. Therefore, that's our h of x that led to the transformation. Right, thank you so much for watching. Please like, share, and subscribe, and stay tuned for more videos.